Hello everyone, welcome back to my video. So in today's video we'll be discussing about Dijkstra's algorithm, and this video will be discussing about this algorithm in terms of an undirected graph. In the upcoming video we'll be discussing in terms of a directed graph. Okay, so Dijkstra's algorithm is known as single source shortest path. Why do we call it as single source shortest path problem? Is because you'll be selecting one single source, and from that source you will be finding out the shortest path to go out to our next destination source. Okay, so this algorithm may sound confusing to someone who is listening it for the first time, so I request you all to please pay 100% attention to this. So the first thing that you're going to do is you will be selecting one source, which is your starting source. Okay, and you will be putting the value of that distance as 0. Suppose my starting source that I've taken here is 0. You can take any starting source. Suppose they ask you to find implement Dijkstra's algorithm and your source node, that is the starting source, is 3. So now then what I have to do in that case is I have to put the distance of 3 as 0. I have to make the distance of 3 as 0. So whichever is your source vertex, you have to make its distance as 0. This is your first and foremost step. And the distances of the next source vertices, you have to make it as infinity. Okay, that is, what are the leftover vertices? We have 1, that will become infinity, 2 will become infinity, 3 infinity, then this 7 will become infinity. So like that, all the leftover vertices, I will make them as infinity. So I've selected my source vertex, that is 0. Okay, this one. I have made the distance value as 0, and all the leftover vertices will have a source, that is distance value, as infinity. So this is the first and foremost step after you get your source vertex, or whichever source vertex you are choosing, or whichever source vertex they have asked you in the question. Now you have a formula kind of thing, that is the distance of your u plus the cost of going from u to v should be less than the distance of v. Okay, so this, don't get tensed by saying this formula, it is very simple. So what you're doing over here is, now when I'm taking this source vertex, I'm considering it as u. Okay, I will consider this as u, and I'll take one node which is directly attached to this vertex. Like for suppose in case of 0, the nodes which are directly attached is 1 and 4. Okay, let me take the node 1 and make it as v. Okay, now what I'm supposed to do is I have to first check the distance of u. Distance of u, I have considered it as 0. So I'll put 0 plus the cost of going from u to v. What is the cost of going from u to v? That is the cost of going from vertex 0 to vertex 1. That cost is 4. Okay, 4 is the cost when you go from vertex 0 to vertex 1. So I'll write 4 over here. Now this should be less than your distance of v. What is the distance of v? The distance of v is infinity, as we assumed at the starting. So 0 plus 4 is 4, and that 4 is less than infinity, which is true. So if this becomes true, then what you're supposed to do, you have to update your distance of v as the value that you got, that is distance of u plus cost of u minus v. So what was that value? That value was 4. Okay, so this 4 will be updated as your distance of v. Okay, so this 4 I'm going to update it as your distance of v. So initially the distance of v was infinity, but now I'll update it as 4. So I'll cut this infinity and make it as 4. So this is my new distance of 1. Okay, so this is how you're going to check for all the nodes that are attached or adjacent to your previous node, and you're going to check this same formula you'll be applying. You will be adding the cost value, and you will be adding the distance value of that vertex, and you will be checking if it is less than your distance of the destination node. And if it is less than that distance, then you will be updating it with that distance. If it is greater than that distance, then you will be leaving it as it is. Okay, so this part is done. Now I'm going to check the next node that is directly attached to 0. The next node, or the next vertex that is directly attached to 0, is that of 4. Okay, 4 is our next vertex, or you can call it as node. Okay, you can either call it as vertex or node, it is your choice. So again, I'm going to consider this starting node from where I'm starting as u, and the next node where I'm going as v. So again, I'm going to take the distance of my starting node, that is 0. Okay, the distance is 0. 0 plus the cost of going from this u to this v. What is the cost of going from u to v? It is 8, right? So 0 plus 8. What is 0 plus 8? 0 plus 8 is 8. And what is my final distance of 4? The distance of 4 is infinity. Now is 8 less than infinity? Yes, that's true. So I'm going to cut this infinity and update the new distance value of 4 as 8. Okay, so this is the new distance value of the vertex 4. That is 8. Previously it was infinity. Now the new distance value is 8. So now that you can see, the nodes that were directly attached to the node 0 were 1 and 4. And we have visited those nodes and we have updated its distance values. So now I'm going to cut this vertex 0. Why am I cutting that vertex 0? Is because I'm depicting it that I have visited this node. This node 0 is a visited node. So now I need not come back to this node, or now I should not check the edges that is attached to this visited node. Okay, we can ignore this node now. That part is done. So moving on, we have distances left for our different nodes. So if you can see here, we have distances like 4, infinity, 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 here also infinity, infinity, and here 8, and here also infinity. So out of all of these distances, that is 4, 8, and then we have 1, 2, 3, 4, 5. 5 infinities. Okay, so we have 5 infinities over here. So out of this different distances, that is of the distances of the leftover vertices which are not visited, you have to compare these distance values and check out the distance value which is the minimum. So the minimum value in this is 4, right? Minimum value is 4. So 4 is the distance of which vertex? It is the distance of vertex 1. So now I'm going to consider my vertex 1 as my source vertex or the starting vertex. And now I will follow this minimum spanning tree steps. That is, I'll follow again these steps and I'll check the nodes that are directly attached to 1. So 4 is my minimum distance. Minimum distance of which vertex? Vertex 1, right? So now let me choose 4. That is my vertex 1. I have chosen vertex 1. Now my vertex 1 becomes my main starting vertex. Okay. So now from vertex 1, which are the vertices that are directly attached to this vertex 1? So if you can see here, this vertex 0, 2 and 4. There are 3 vertices that are directly attached to vertex 1. And now I'm going to consider these 3 vertices. But one more thing that I have to consider here is the visited vertices. If you can see here, 0 I've already cut it because 0 is a visited node, already visited. Now the nodes that are already visited, we should not consider it, as I already told in the starting. So I'm going to not consider this part and I'll consider only the vertices 2 and vertices 4 and update its distance values. Okay, and I'll be leaving out this vertex 0 because it is a visited vertex. Okay, so now I'm going to check from 1 to 2 and 1 to 4. So first let me see 1 to 2. Now the distance of 1, that is vertex 1, is 4. You can see here the distance is 4. Now let me write it over here. So the distance is 4. 4 plus what is the distance or the cost of going from 1 to 2? The cost of going from 1 to 2 is 8. Okay, you can see here the cost of going from 1 to 2 is 8. So I'll add 4 plus 8. What is 4 plus 8? 4 plus 8 is 12. Is 12 less than infinity? That is why am I taking infinity? Infinity is the distance of vertex 2. So 12 is less than infinity, right? So I'll update the distance as infinite as 12. I'll cut this infinity and I'll update the new distance as 12. So 12 is my new distance of vertex or of node 2. Okay. Now I'll check the next direct node that is connected to node 1, that is 4. So now my distance of node 1 is 4, right? 4 plus what is the cost of going from this node to node 4? The cost is 11. You can see here the cost is 11. So I'll add 4 plus 11. 4 plus 11. What is 4 plus 11? It's 15. Now what is the distance of my source node where I'm going? When I'm going from 1 to 4, the final distance of my of my destination node, that is 4, is 8. Okay, final distance is 8. Now the question is 15 less than 8? No, right? 15 is not less than 8. So I should not cut that 8 and make it as 15. Right? I read that 8 remain as it is. Now suppose I add these two numbers and suppose I get something which is less than 8. Suppose I end up getting a number like 6 or 5 or 3. Then I'm supposed to cut that 8 and write that 6 or 5 or 3 over there. But since I got 15 over here, which is greater than 8, that is, this condition is not satisfied. So I will not be updating the new distance value and my original distance will only be there. That is, 8 will only be the value over there. So I'll let my 8 remain as it is. Now you can see that I have visited the vertices that were directly attached to node 1. So now I'm going to eliminate this node 1 because this becomes a visited node. That is, all the nodes that were attached directly to the node 1 have been checked, their distances have been updated. That is, if the distance that we found out after calculating was less than the distance of my destination node, then I'm going to update it. If it is not less, I'll let it be as it is. Now I've done that part for all the attached vertices. So now I'm going to cut that 1. And when I cut it, it means that 1 is a visited node. So now I will not be considering it for my future purposes. Okay, so now what are the values of the distances of the remaining nodes which are left over? So the remaining nodes is 4, 5, 6. Okay, let me go in order. We have 2, 3, 4, 5, 6, 7 and 8. These are my remaining vertices. And what are their distances? The distance of 2 is 12. Okay, you can see here, this is the distance value. So the distance of 2 is 12. The distance of 3 here is infinity. The distance of 4 is 8. Okay, this is the distance of 4, that is 8. Then the distance of 5 is infinity. That of 6 here is infinity. That of 7 is also infinity, and of 8 is also infinity. So out of all the leftover vertices, ignoring 0 and 1 because it is already visited once, so out of all the leftover vertices, you have to check the vertex which is having the least or the minimum cost or the minimum distance. So the minimum distance here is of vertex 4, that is 8. So now my next vertex which I'm going to consider as the source vertex will be vertex 4. And now I have to see the vertices that are directly attached to 4, ignoring my visited nodes. So I hope you're getting the concept now. So now I have got my vertex 4 with a minimum distance of 8. Now which nodes are directly attached to vertex 4? My nodes 0, 1, then node 8 and node 5. These are the nodes, that is 4 different nodes are directly attached to vertex 4. But I'm going to ignore 0 and 1 because they are the visited ones. And I'll just consider vertex 8 and vertex 5. And I will update their distance values. Okay. So what is the distance value of vertex 4? It is 8. Plus what is the cost of going from vertex 4 to vertex 8? The cost is 7. So what is 8 plus 7? 8 plus 7 is 15. Right? And now 15 is less than this distance value. Distance of cost, that is my destination node, is infinity, right? 15 is less than infinity. That means the time has come to update. So I'll cut this infinity and make it as 15. So I've done visiting 4 to 8. Now I will check the node 4 to 5. That is this node. Okay. And I will put the same operation for them. Now what is the distance of 4? Distance of 4 was 8 as it is, plus the cost of going from 4 to 5. The cost of going from 4 to 5 is 1. 8 plus 1 is 9. Now what is the final distance of the destination vertex? That is infinity, right? So is 9 less than infinity? Yes, 9 is less than infinity. So time has come to update the value. I'll cut infinity and make it as 9. Okay, so now that I am done visiting all the direct vertices that were attached to 4, so I'm going to cut this vertex 4. So now I have 3 visited nodes, that is 0, 1 and 4. So these nodes are visited. Moving on to our next nodes. Now what are the values of the leftover nodes? 2, 3, 7, 6, 5 and 8. These are our leftover nodes or vertices. And what are the distances? The distance of 2 is 12, of 3 is still infinity, 7 is also still infinity, 6 is infinity, 5's value just got updated to 9 and the value of 8 is 15. Now out of all these distance values of these vertices, which one is having the minimum distance value? 9 here is the minimum out of all these values, and that 9 belongs to vertex 5. So our next vertex or the source vertex will be 5. Okay, so our next vertex is 5. Now see all the vertices that are directly attached to 5. 4 is directly attached to 5, but I have to ignore it because it's visited one. 8 is directly attached to 5 and 6 is directly attached to 5. So now I'll check first 5 to 8 and then 5 to 6. So now let us go a little faster. So what is the distance of 5? Distance of 5 is 9 over here. Okay, distance of 5 is 9. So I'll write 9 plus the cost of going from 5 to 8. The cost of going from 5 to 8 is 6, right? See, all the blue ones are the cost over here and the green ones are the distances of those vertex. So 9 plus that 6. Now what is 9 plus 6? It's 15. And the final distance of vertex 8 is also 15. Now 15 and 15 both are same value, so there's nothing to change or update over there, right? So that vertex is done. Now let me go from 5 to 6. Now I'm going from 5 to 6. Now what is the distance of 5? The distance of 5 is 9. What is the cost of going from 5 to 6? The cost is 2. So 9 plus 2 is 11. Is 11 less than my distance of destination? What is the distance of 6? Distance of 6 is infinity. Is 11 less than infinity? Yes, it's less than infinity. So time to update. Cut infinity, put 11. Okay, done. Now we have visited the vertices. Now I'll cut 5. 5 is also one of the... Now my 5 also becomes one of the visited nodes. Now what are the leftover nodes? 2, 3, 7, 6, 8. Okay, these are the leftover vertices. And what are their cost values or what are the distance values? Distance value of 2 is 12, of 3 infinity, 7 infinity, 6. 6 is 11. Okay, just now updated the value of 6. And the value of 8 is 15. Right, let me cross check. For 2 it is 12 here. For 3 it's infinity. For 7 also infinity. And for 6 we have 11. And then for 8 we have 15. Now which is the smallest value out of all these values? 11 is the smallest. 11 belongs to vertex 6. So 6 becomes our next source vertex. So now let me apply the same operation. The distance of 6 is 11. 11 plus what are the nodes that are directly attached to 6? We have 3 nodes over here. 1, 2, 3, 4 nodes are present over here. But one of them is visited, that is 5th node. That is from going from 6 to 5. It is already a visited node, so ignore that. We will be checking from 6 to 2, from 6 to 3 and from 6 to 7. So from 6 to 2, when I go from 6 to 2, what is the distance of 6? The distance of 6 is 11. Plus what is the cost of going from 6 to 2? The cost of going from 6 to 2 is 4. So 11 plus 4. What is 11 plus 4? 11 plus 4 is 15. Now what is my distance of 2? Distance of 2 you can see here is 12. Now is 15 less than 12? No, it's not less than 12, so we are not supposed to update it. Now let me go from 6 to 3. Okay, 6 to 2 is done. Now when I'm going from 6 to 3, distance of 6 is 11 plus the cost of going from 6 to 3 is 14. Now what is this distance? This becomes 25. 25 is less than infinity. Infinity is the distance of 3. So it's time to update the value. I'll cut this infinity and make it as 25. This is my new distance of 3. Now I have done 6 to 2, 6 to 3 is done. Now I'll do 6 to 7. Okay, from 6 to 7, the distance of 6 is 11, plus the cost of going from 6 to 7 is 10. This becomes 21. So now 21 is less than our infinity, right? So now I will be cutting this infinity and make it as 21. Now this becomes my new distance value. So now that I've visited all the nodes that were directly attached to this, it's time to cut 6 as well. This also becomes my visited one. Now once again we will write all the leftover nodes. So we have 2, 3, 8 and 7 left. And what are their distances? The distance of 2 is 12, that of 3 is 25, that of 7 is 21, and that of 8 is 15. Now which is the minimum value in this? 12 is the minimum value, belongs to vertex 2. So now my next source vertex is 2. And what are the vertices actually attached to that? We are going to the visited node 1. We are going to vertex 8. Then again we are going to vertex 6, which is one more visited one. And then vertex 3. So now I'm going to check all the unvisited ones. So first I'll go from 2 to 8 because 2 to 1 and 2 to 6 are already visited. So 2 to 8 I'll check. Now what is the distance of 2? The distance of 2 is 12. 12 plus cost of going from 2 to 8 is 2. 12 plus 2 is 14. Is 14 less than distance of 8, which is 15? So is 14 less than 15? Yes, it's less than 15. So cut the previous value, make it as 14. The next one is I'm going from 2 to 3 because 2 to 6 is already done, visited node. So 2 to 3. What is the distance of 2? 12 is the distance of 2 plus distance, that is cost of going from 2 to 3 is 7. 12 plus 7, which is 19. Now what is the distance of 3? Distance of 3 is 25. Is 19 less than 25? Yes, 19 is less than 25. Cut it, make it as 19. Now all the nodes are visited, right? 2 to 1 was visited, 2 to 8 done, 2 to 6 already visited, 2 to 3 done. So cut 2 as well. Okay. Now write our leftover ones. Leftover is 3 and 7. What is the distance of 3? 19. The distance of 7? 21. Which is the lesser one? Okay, we have one more one, that is 8. Right? So we have 3, 7 and 8. Right? So the distance of 8 is 14. So out of all of these, that is 19, 21 and 14, which is the smallest one? 14 is the smallest value of which vertex? Vertex 8. Right? So now I'm going to select vertex 8. Now which are the nodes directly attached to vertex 8? This is the first, that is 4. This is the second, that is 5. And this is the third vertex. Now if you see, all these vertices that are directly attached to 8 is visited. Okay, all of them are visited. Now that all of them are visited, there is nothing to update. So you will let 8 as it is remain. Okay, so now 8 is also gone. And 8 is also our visited vertex. Because all the nodes that are directly attached to 8 are already visited. So there's nothing to check or update now. Now what are the leftover vertices? We have 3 and 7 left. Now what is the smallest value in this? 19, which belongs to vertex 3. So now my source node becomes 3. And now I'm going to check the vertices. So 3 is attached to this one, that is 2, which is visited, ignore it. 3 is attached to 6, visited, ignore it. 3 is attached to 7. So check for 3 to 7. Distance of 3 is 19 plus the cost of going from 3 to 7 is 9. What is 19 plus 9? 28. Now what is the distance of 7? Distance of 7 is 21. So is 28 less than 21? No, it's not less than 21. We will not update the value of 7. So now that we have checked all the vertices, 3 is now my visited vertex, and what is the leftover vertex? 7. So there's nothing to go from 7 because 7 has got 3 and 6 attached to it, but they are also visited. So now 7 also becomes a visited node. So we have gone everywhere and we have visited all these nodes over here. Okay, so now what is our final distance or the shortest path? Now suppose they ask you a question about the shortest path. So I'll just mark your shortest paths, that is 4, here 12, okay, here 19, here 21, 11, in this case 9, in this case 8, and here 14. Okay, these are my shortest path. Now suppose they ask you a question that you're trying to go from node 0 to node 7. What will be your minimum total weight? That will be 21. Okay, this here is 21. 21 will be your total minimum weight when you go from vertex 0 to vertex 7. Right? Now suppose if I ask you that 0 is your source vertex and you're trying to go from 0 to 4. So what is the value? 8 is the value here. So 8 is the minimum value or the minimum total weight when you're going from vertex 0 to 4. Similarly, you're trying to visit vertex 0 to 8. So in that case, 14 here which is present is your minimum value. If you're trying to visit from vertex 0 to 6, then here 11 is there. 11 becomes your minimum value. So this is how you can find out the minimum value when you're trying to visit from your source vertex. So your source vertex here for this question is 0, and from this source vertex, whichever vertex you go, those circled values will be their minimum total weight value. So this is how you apply Dijkstra's algorithm for an undirected graph. So I hope you understood the concept of this video. In our upcoming video, we'll be applying Dijkstra's algorithm for a directed graph as well. So thank you for watching and meet you in my next video.